let's get started here. We're going to talk about rotation of axes. Previous lesson we looked at this general equation for a conic over here, and we saw that we could change the different values to get ellipses, hyperbolas, parabolas, whatnot. But at the time we had a restriction where b was equal to 0. Basically there's no xy term. So what we mentioned last time was that if we did have an xy term, what's going on is the conic. Let's just keep it with an ellipse for the purposes of our discussion right here. So the ellipse over here, once we change the value of b, which let me just do that right here, we can see that it starts to rotate basically. Okay, no longer nicely oriented with the x and y axis. So this kind of presents a problem based on what we already know. We've been doing things such as completing the square to find the center of the ellipse. But in this case, if it's not oriented with the xy axis, we can't really do that anymore. So the idea of rotating axes comes into place such that we can actually change the orientation of the xy axes basically to match the orientation of the ellipse. Let me turn on the alternate axes over here. Okay, so look at this. So imagine that you could see this ellipse right here. It's not oriented with the xy axis over here, but with this alternate set of axes over here, I'm going to call this x prime and y prime over here. Watch what happens. Let me change the value of b. So imagine if we rotated the axes to match the orientation of the ellipse. That would just make things a lot easier to work with. So that's what we're going to explore over here. So let's get going on a proof of what we need to do over here. Okay, we'll start out with the xy axes that we're familiar with. So I'll draw that over here. All right, so there we go, xy. And we'll start out with a point. We'll put point P. Let's put that right about here. This is point P with coordinates xy. Okay, just a point that I placed over here. Let me also draw in. Let me draw in a ray through that point. All right, there we go. Okay, so imagine that we wanted to rotate the xy axes. Draw an alternate set of axes over here. So maybe something like this. That through the origin. And let's draw in the perpendicular line over here. Let me try this. Okay, that's about perpendicular over here. I'm just eyeballing it right here. Okay, so perpendicular. All right, there we go. Pretty close. And we're going to call this an alternate set of axes over here, x prime and y prime. Let's add a few more things here. We should note that what we're basically trying to do is we're trying to convert from these coordinates, xy coordinates in the xy plane, to alternate coordinates in the x prime, y prime plane. So in the x prime, y prime plane, the coordinates of the point would actually be x prime, y prime. All right, so let's draw in a few more things over here. Okay, so let me drop this line over here from that point. Drop that straight down. and that is a right angle right here. Okay. Actually, before I did that, I probably should have drawn a couple of angles in. So let's say that this angle right here, we're rotating through this angle. Let's call that theta. And let's get this angle over here. Let's get that labeled as well. That right here, we're going to call alpha. All right, let's start labeling a few things. Let's look at this triangle first right here. This triangle right here. First of all, if we think back to polar coordinates, we would basically label this length right here r. So I'm going to label that r. Okay, that's r. And thinking back to basic trig, this length over here, which is length x, we could write that in terms of r and the angle over here. So we'll start with that. So x is equal to r. You probably remember this from working with polar coordinates. X equals r cosine of this angle right here. And we can see that that angle is theta plus alpha. Okay, so that takes care of x. We also have this distance right over here, which is y. So I'll label this y. Once again, the entire line over here is y. So y is equal to r times sine of this angle right here. Theta plus alpha. Okay, so we looked at that first triangle over here. Let's draw on another triangle over here. All right, let me drop this down here. Actually, let me make a little room here. I'm gonna put this y over here. Let me fix this right here. Okay, draw this line back in over here. I'll write y over here. Okay, so let me drop this other line over here straight down. Straight down. Okay, but it's actually perpendicular to the x prime axis. And we're going to come up with similar measurements over here for x prime and y prime. So right here is x prime. Let me label this length over here x prime. And this length right over here is y prime. Okay, and remember, we're basically giving the x and y coordinates relative to the x prime and y prime, or I should rather say the x prime and y prime coordinates relative to the x prime and y prime axes. So let's write those out over here. Okay, so we have x prime is equal to, it's the same r over here, r times cosine, but this time you could see the angle over here is just alpha. So we could write that down over here, alpha. For y prime over here, we have y prime is equal to r sine theta. Our basic trig. Okay. So we're getting close to the part which we wanted to get to, which is setting up the relationship between x and the x and y and x prime and y prime. So let's get that set up. I'm going to expand this out over here. We have some identities that we can use, trig identities. So x is equal to r, and we can expand this. This is a sum here. So we could expand this as, if you remember your identities, all right? cosine theta cosine alpha minus sine theta sine alpha. Okay. Let's go ahead and do a little bit of rearranging over here. I'm just going to rearrange the terms. So I could rewrite this first one as r cosine alpha times cosine theta. We'll do a little bit more creative rearranging over here. This is r sine alpha times sine theta. Okay, but now we can look back over here, basically. Look here. We have a r cosine alpha over here. Over here, we have a r sine alpha. So we could start doing some substitution. Okay, this becomes x prime. Once again, r cosine alpha is equal to x prime. So we'll substitute that in. Times cosine theta minus, here we have r sine alpha, which is equal to y prime sine theta. Okay, so let me go ahead and kind of box this right here. Okay, so we have x is equal to x prime cosine theta minus y prime sine theta. Let's do a similar thing for y. So y is equal to r sine, this is from up here, r sine theta plus alpha. And let's expand that out. We have another identity that we can use over here. So this is equivalent to r times sine theta cosine alpha plus cosine theta sine alpha. Let's do a little bit of creative rearranging again. We'll rewrite this as r cosine theta times sine theta plus, I'm going to distribute this r sine alpha times cosine theta. We're almost there. We'll do some substitution again. We could see we have r cosine theta over here, which is equal to x prime. So we can rewrite this as x prime sine theta plus r sine alpha, which is y prime. Y prime cosine theta. And there we have our second relationship over here. So to summarize, what we've basically done is we've done a rotation of axes through this angle theta over here. We started out with x, y, and we rotated by theta and got to x prime, y prime. So what we've done over here is we've shown the relationship between x, y, and x prime, y prime. And what you'll see in another video, I'm not going to do it in this video, but we can basically, if we take the original equation, which is given in x and y, and we substitute these values in over here, we could get the new equation in terms of x prime, excuse me, and y prime. And that is going to be beneficial because what we can do is actually rotate through an angle which essentially eliminates the xy term. And we'll save that for another video. That's it.